This week's focus is going to be on fractions. How to draw them, how to shade them, compare them, equivalence, all of that. So I thought I would go ahead and model how to think through and explain a few of the problems from your child's packet this week. One of the example problems is here below. It says this number line is divided into how many pieces? So here, when it says pieces, we're talking about counting the spaces in between the lines. Do not count the lines. If you do, you would find that there are 9 lines. And you might think that it would be ninths, but that would not be correct. You want to count the spaces in between, which would be 8. Knowing that it's split into 8 pieces, I can go ahead and label my fractions as eighths. That will help me with question 2, which says, what is the location of A written as a fraction? If I were to have labeled all of those parts, I would see that A is 4/8. Another similar problem, but with slightly different questions, says on this number line, what is the value of 1 written as a fraction? Well, again, I would have to figure out how the fraction has been divided. And again, it's in eighths, and we count by doing the jumps or the spaces. And if I stop and find where 1 is, the fraction at 1 is 8/8. Question 4 on this number line from B to C is how far written as a fraction? Well, to go from B to C is 1 jump. I'm changing from 0/8 to 1/8. So the answer is 1/8. Then when it gets into comparing fractions, drawing a picture is the best way to do this. So here you can see I've drawn 2 fraction bars, 1/4 and 1/2. They are both the same size, which is very important when it comes to comparing fractions. And when I shade 1/4 and 1/2, I can clearly tell that 1/2 is larger than 1/4. So the rule that we've taught the kids to help remember is that when they have the same numerator, here it's 1, the smaller denominator is the larger fraction. When talking about equivalent fractions, we're talking about fractions that show the same amount. Here, my first fraction is showing 1/3. For showing the same amount, I need to make sure the shaded parts are the same size. So I would need to shade 2 pieces here of the total 6, and I would find that 2/6 is equal to 1/3. To show it on number lines here, I would have to label first the 1/4 and then figure out what the second number line has been split into, which is eighths. There I can see that 1/4 and the fraction 2/8 line up together, meaning they both stop at the same place on their number lines. So that's how I know those fractions are equivalent. Now to get into some of these trickier word problems with fractions, it says which point is at 4/4 on the number line. Now, this number line is different than most number lines that students are used to seeing. This number line goes from 0 to 1 and then all the way up to 2. Normally the fraction bar number lines go from 0 to 1 and stop. So that's why I've color coded so you can clearly see that they would have to draw 2 separate fraction bars if they wanted to think about it that way. Each part though, from 0 to 1 and from 1 to 2 is considered one whole. So from 0 to 1 it needs to be split into 4 parts, and then from 1 to 2 you could split into 4 parts. But if I start labeling them with fourths, I would see that 1/4 lines up with the number 1, and the letter at number 1 is T. Next word problem says that this large rectangle is divided into equal parts. A student said that 2/6 of the rectangle is shaded. Why is the student not correct? Well, if we look, they're right that there are 2 shaded parts, hence the numerator of 2. What they got incorrect was the total number of parts, which is actually 8. I still count those shaded parts in my total, whereas this student counted only 6 unshaded parts. Here, the correct answer is D. There are more than 6 parts in the whole. There are actually 8. Our next question says that Stacy read 2/3 of a book. Evan is reading the same book. He has read just as much as Stacy. Which equivalent fraction, or the same, to the book that Stacy read? So here, they're not given a model to look at. So I would encourage your child to draw the first fraction, 2/3, to show how much Stacy has read. Then I would draw my 3 answer choice fractions below, making sure the fraction bars are the same size. They need to stop and start at the same place. They also need to carefully divide the fraction bar into equal pieces. After you have done that and shaded, you can clearly tell that the 2/3 and the 4/6, their shaded parts line up at the same place. The 6/8 and 4/5 fractions are larger than 2/3. So the answer is A, 4/6 is equivalent with 2/3. Next question, you have 1/3, 1/6, and 1/8, and I've drawn a model of them to go along with it. It says describe how the denominator changing, meaning the bottom number, total number of parts, affects the size of the fraction. Use models or drawings to support your answer. So here, the larger denominator is the smaller fraction, or that the pieces will be. This is because it is being split, but the amount isn't changing. Meaning, as I make more and more pieces within this same size, they're getting smaller. But if I split it and share it less, my pieces will be bigger. And then just some real life situations that you could think of when you talk about fractions: cooking or baking recipes, measuring, pizza slices, cutting brownies, anything where you're having to slice or cut and share things equally.